This is the fifth proof of the Pythagorean theorem. This one is attributed to Leonardo da Vinci. I took away the black paper, as I showed in the other ones, because this one requires a bit more sketching than just moving the pieces around. You can start with the two squares, the small one and the medium one, and you can trace around them. So I'm going to make the two squares like this. So this is the first step. And you say this is the area A squared and this is the area B squared. So this is A and A, this is B and B. The first step, we call it cut number one. And in cut number one, we start with our two squares, just like we had them, and we cut down the diagonals, and we're shading in those two parts. The next step is called the swap. We're going to take this piece and put it up there, and this piece goes down, so they're swapping positions. Now it's a little funny to draw, so I start off by drawing the way that I had it, and I draw in the cut, and then I cut that part out, or I erase that part. And if you need the square to help you, you're going to have your pieces with you, so you draw, this is the B, that's this piece here that went up there. I don't think I really, oh yeah, I can shade them, that's fine. And this piece here, this is the A. If it helps, you can number them. You can say this is piece 1, and this is piece 2, so that when you swap them, it makes it very clear. If I can make that a little bit more like a square, half a square. This is 1 and this is 2, and you're going to be tracing your pieces. I'm not doing that with the pen because I'll mark all my pieces up. But you do that. So that's the swap. And then the next thing we want to do is cut number 2. And the way that we cut them is we're going to cut from here down to there. And remember that this is A and this is B. This is B. And this is A. So we're going to cut from here to here, and we're going to cut from there to there. So first I have to draw it. I would trace out my A, trace out my B. I would do my cuts there. Then I would redo those. So there's my B and my A. Okay, so now I'm going to use my triangle because this is A and this is B. So I'm going to use my triangle and I'm going to cut here. Okay, so this is piece number 3. And I'm also going to cut here because this is B and this is A. So this is piece number 4. And I'm also going to put hinges on there. So I'm going to put a hinge there, and I'm going to put a hinge there. And I can really start leaving off these lines at this point. I don't need to have those lines once I've slid the pieces around. So with this hinge, this piece is going to rotate there, and that piece is going to rotate there. And we understand that because this was the triangle and this was A and this is B, then this is C. And the same thing here, that's A, that's B, that's C. So when we rotate the pieces through, so here's rotate, then what we end up getting is the C squared. A squared plus B squared got cut, manipulated around, and it gave us c squared, and thus we have proved what we set out to prove.